Awesome. Okay, welcome to the homework 7 problem 4. This is problem 5.035, area of a centroid. In this problem, we are determining the centroid of the area shown by direct integration. Okay, so before we start, it's good to denote a few things just about um, y1 and y2. So what we have here is that we know the change in x and the change in y. So we can use that information to figure out what m and k equal in these expressions. So by doing so, we start off with these expressions here, and then we can solve for m and k in terms of b and a. And then this is just important information to note for later, because it'll, at the end, when we're trying to simplify our equations to only have a and b for these final expressions, we'll be able to get them. So, second point about direct integration here is that we're just taking all of these little vertical uh, change in areas, right? So this is uh, dA, which we can also denote as like that. Um, sorry, that we're also going to use to figure out our little use our knowledge about x and y to determine that total area, and then once again use a similar method um, as earlier to figure out our centroids. So when we're looking at that little area here, we know that the estimated center, or the center for x of this little subsection, will still be just x, because it's like we're assuming it's infinitely small. So it won't have any thickness really. So for y, we're assuming that the estimated y height is just in between the two, right? Because we want the center of this this little area. So that would be that it's just 1/2 y1 plus y2. And then lastly, we want the change in area. So change in area will just be the change in height times the change in width. So that's y2 minus y1 times dx. So using all that information, we can now go through and try and simplify everything as much as possible. So the first thing we're actually going to do is we are going to look at dA here. So we found an expression for dA, and I'm just going to leave it in terms of k and m. But what we did essentially is we just said, okay, so I know y2 and y1. I'm just going to plug in these expressions for it. So after you plug in those, what you can do is we're just going to integrate to figure out what a is. So to do that, we're going to integrate from 0 to a, because that's the bounds of our x. And then you'll just go through that process of directly integrating. So once you do that for a, you'll end up with this expression right here. So you'll have 2k a to the 3/2 power divided by 3 minus ma squared over 2. With that, we can now substitute in the values for k and m that we found above. And those values were m is b over a, and then k is b over a to the power of 1/2. So when we do that, what we get is that we can actually simplify it so there's only b and a in this expression. And this gives us that the area is 1/6 BA. So next thing we can do, so we have knowledge about the area. So similar to how we did it before, we also now want the integral of that x bar dA, so we can divide this expression by just the area as well, right? Because that's going to give us that centroid x bar value. So when we're doing when we're looking at this problem on the right here, so we have that x bar times dA. Once again, we have all our information from above here, so we have everything we need to know. And so similar process, just directly integrate that. And once you go through those steps, you'll get to this expression right here. And then in order to simplify, you'll get to the step right before here. And then after you plug in A, and then the next step would be to plug in M and K so that you can simplify to only have BA squared. And that'll get you this 1/15th BA. So after you do that, you would perform a similar process to find that estimate for y bar for each change in area. So I'd say just pausing here and trying that if you haven't. And then looking at that, we'll have it's a similar setup. We're just plugging in what our value for that we found up here, and then are multiplying it by the area or that change in area. So once again, go through the steps of trying to determine that y bar. And then once again, you'll get an expression with m and k. And then you'll just plug in the values for m and k that we found above. And then this will simplify to 1/12 AB squared. So now that we have all of that information, what we need to do is we need to combine it all. So we have A, we have this expression here, and we have this expression here, right? So we know these three, and we need to figure out, okay, how can we use all of those to determine the centroid location? So similar process as we did before in the previous problem, right? We're just summing up all of the individual centroids times A over A. And the reason when we take the direct integral, we sum all of those areas up, which means that we can just use what we found for x bar A up here and divide that by the total area. And if you do that for both x and y, you'll get that x bar equals 2/5a and y bar equals 1/2b.